The RISC-V Server SoC spec defines the complete blueprint for building a data center class system, combining compute, memory, I/O, virtualization, and reliability into a standardized platform. Section 1 describes overview of minimum hardware capabilities required to run modern operating systems and hypervisors in a portable and interoperable way. Server SoC specification targets data center class systems with high performance compute, scalable multi-core, multi-socket support, virtualization readiness, rich I/O and memory bandwidth, enterprise features like RAS, security, and manageability. So Server SoC spec establishes a standard hardware contract for RISC-V servers. Section 2 shows major subsystems and how they connect. The SoC is organized into core building blocks. The multi-core clusters, coherent interconnect, memory subsystem, I/O subsystem, platform services, system agents. These components are connected through an on-chip network. So Server SoC is a modular architecture connected by a coherent fabric backbone. Section 3 shows CPU and HART capabilities. Server class HARTs support 64-bit general-purpose registers, vector extensions for AI and high compute operations, hypervisor extensions for virtualization, supervisor and user privilege modes, SMP and cache coherency, per heart interrupts, performance counters and timers, and optional debug and trace. So these server class CPUs are designed for parallel, virtualized, high performance workloads. Section 4 shows memory hierarchy of caches and memory modules. Typically, server SoCs have L1 caches for instruction and data, L2 caches per cluster, L3 caches that are shared across cores, a main memory module, it could be either DDR or HBM. DRAM controllers in server SoCs have multi-channel DRAM, high bandwidth, and NUMA awareness for scaling. So hierarchical caching, high bandwidth memory equals performance at scale in server SoCs. Section 5 describes I/O and connectivity to show external interfaces and device connectivity. The I/O subsystem includes PCIe support for Gen 5, Gen 6. Example PCIe devices are GPUs, AI accelerators, NVMe storage, network interface cards. PCIe can also include some advanced features like single root I/O virtualization, address translation service, page request interface, process address space ID. Memory expansion and USB SATA could be optional interfaces. These interfaces and I/O subsystems enable high throughput data movement for I/O, storage, and networking. Section 6 describes I/O memory management unit for device memory virtualization and protection. I/O MMU translates I/O virtual addresses to physical addresses. It enforces access permissions and also provides per device isolation. Apart from that, it supports IOTLB caching, two-stage translation, and fault reporting via queues. So IOMMU gives devices secure, virtualized access to memory. Section 7 describes advanced interrupt architecture for modern interrupt handling system. AIA includes MSI First Interrupt Delivery, IMSIC, which is per heart interrupt controller, low latency scalable interrupt routing, virtualization friendly for direct guest delivery, elimination of centralized bottlenecks. So, distributed interrupts mean scalable and cloud-ready SoC. Section 8 describes hardware support for virtual machines. Virtualization is supported in various ways. Hypervisor board, virtual CPUs mapped to hearts, virtual interrupt controllers, IOMMU with two-stage translation, memory and interrupt virtualization. Virtualization benefits include low virtual machine overhead, secure isolation, efficient device pass-through. So full stack hardware support for virtualization in cloud and multi-tenant systems is available. Section 9 describes RAS, reliability, availability, and serviceability. RAS features include error correcting code for correcting single bit errors in memories, chip kill memory protection. It scatters data across multiple chips, allowing the system to reconstruct data if one chip fails completely, preventing system crashes. Error detection and correction. RAS also includes fault reporting and logging, watchdog timers, crash dump and recovery mechanisms. Last but not the least, telemetry and health monitoring. RAS ensures high availability and fault tolerance. Section 10 describes management and monitoring for system control and observability. It includes BMC or remote management interface, which is optional, telemetry services, power and thermal management, performance counter monitoring, secure firmware updates, and the last one is debug and trace support. So management and monitoring enables data center grade operations and control. To sum it up, all the key features of a server SoC are outlined in the bottom of the slide.